Now we're going to talk about electrical power. Now, just to review, power is the rate or how fast a machine or a device converts energy or transforms energy from one form into another. So it's how fast a device can transfer one form of energy into another. When we start talking about electrical power, it's how fast an electrical device can turn electricity into some other form of energy, such as light bulbs create light or electromagnetic energy. They also create heat or thermal energy. Electrical motors take electricity and convert it into motion or kinetic energy. Now we measure power or electrical power just like we do dynamic or mechanical power, which is in watts, and 1 watt is 1 joule per second. Now, if we think about this, and we think about it in terms of light bulbs, a 100-watt light bulb does 10 times the work of a 10-watt light bulb because its power rating is 10 times as much. So, in the same amount of time, a 100-watt light bulb will do 10 times the amount of work, or it'll convert 10 times the amount of electricity into light, which is why we have a brand of light bulb. All right. Calculating energy consumption. Well, the energy used by an object in joules equals the power of that device times the time at which we're running it. And so, how much energy is used to run a 100-watt light bulb for 1 minute? Well, remember, power is watts, which is in joules per second, and so our time must be in seconds. So if I were to calculate this, I know that the power of the light bulb is 100 watts. I also know the time, T, equals 1 minute, which equals 60 seconds. And so how much energy, E, is my question mark. And so E equals power times time, which equals 100 watts times 60 seconds, which equals 600 joules. So the amount of energy used by a 100-watt light bulb in 1 minute is 600 joules. Now, if you think back to mechanics and you do some thinking there, you probably come up with what would be the equivalence of raising a 1 Newton weight and how far you'd be able to lift it using that much energy. You'll find that it is quite significant. All right. So the equation for power is gotten by just power equals current times voltage. Now, current is measured in amps, and 1 amp equals 1 coulomb per second, because that's a flow of charge, and voltage is measured in volts, and 1 volt equals 1 joule per coulomb. And so if I look at this, I get coulombs per second times joules per coulombs, and my coulombs will cancel, and I get joules per second. So there's a quick check to make sure that we are correct in our assumption of our units. And so current times voltage equals electrical power. Okay, so let's talk about power in your house. Everybody has a circuit breaker in their house. If your house is a little bit older, it might have something called a fuse box, but you have some kind of device that is used to interrupt electrical current if something happens, if too much current is flowing through your house. Believe me, it is preferable to have this breaker shut off than to be faulty and stay on. If the breaker stays on, well, then you're going to run into issues with fires. Now, on each breaker, there is a number. So here's a 15, a 20, and a 15. And normally they go from 15, 20. You might see a 30 or 40 amp breaker, but those usually take up 2 spots. And the 30 or 40 amp breakers would be like your air conditioner, your hot water heater, your dryer, your stove. But 15 to 20, these are, you're looking at just normal rooms, such as the lights or the outlets. I have one specific for my microwave and one specific for my jacuzzi, but here's the whole family room on one 15 amp breaker. Now, house outlets have a standard 120 volts across them, and it might fluctuate a little bit. It might go all the way down to 110, or it could go up to 125. But that's one thing nice about electricity is it doesn't have to be perfect. We just know that it's somewhere around 120. And so everything that plugs into the standard outlet has 120 volts across that. So using that, we can actually figure out how much current does a device use. And so why do we need to know this? Well, we've all been in a situation where we've been playing our favorite video game at 2 o'clock in the morning on our computer, running max graphics, drawing as much power as we can, and you flip on the coffee pot and your whole game shuts down. Well, maybe you haven't been in that exact scenario, but we've been in some scenario where we've been doing something and all of a sudden the electricity goes off someplace in the house. And we have to figure out why. Now, usually the first thing that you do is you go, Mom! Or Dad! I blew a breaker, and then they go fix it. But this is really what's going on in the electrical circuit in your house, and that is because you have drawn too much current through that breaker. Now, every device that you have has a data plate on it. So here is my microwave, and we saw the breaker for it earlier. And this is actually the one that I took a picture of inside my microwave. And every device that uses electricity is required to give you how much electricity they use. Now, you want to look at the incoming wattage because this is how much it's going to be drawing from the wall. So it says here that I'm going to get an input of 120 volts with an 1800 watt single phase worth of power. So that means 1800 joules every second is what my microwave is going to use on a 120 volt circuit. So using this data plate, you can actually calculate how much power or how much current is going to be used by that device. So here we go. We're going to go ahead and calculate how much current is used by my microwave. So power equals voltage times current. And I want to know the current, so I'm going to rearrange this. So I'm going to divide both sides by voltage. So power divided by voltage equals current. Now my power is 1800 watts. And my voltage is 120 volts. All right, and if I pull up my calculator here, so let's go ahead and pull up a calculator. All right, so we just calculated that the current from my microwave is 15 amps. Now, if you remember, the previous breaker said the previous slide says that my microwave is on a 15 amp breaker. So what will happen if I plug something else into it? Well, that's going to increase the amount of current that's going to be flowing through my breaker, which is then going to trip the breaker.